Morning, everybody, and welcome back to AP Environmental Science. We're going to start our review for the AP exam. This is just the informational part of the review. We're going to get into more of the free response type of questions as we get later in the week. Don't forget, this is a shortened week with Easter coming up. So Friday, we don't technically have school. If you want to still work on stuff, though, on Friday, Saturday, and Sunday, and Monday for that matter, you're welcome to do that as well. But we technically don't have to because we're technically, even though we're not at school, those are still considered to be vacation days. So looking at this first unit of review, it's going to be the living world and ecosystems. And when we talk about the living world and ecosystems, the first thing we're going to talk about are the species interactions that we have. And when we talk about the species interactions, we're going to be dealing with symbiotic over here and non-symbiotic over here. If you remember back to when we had class, we talked about what symbiotic meant. Take a second, try to remember back to that, come up with a definition in your mind and see if it matches what my definition is that I'm going to give to you guys. All right, so if you guys came up with your own definition, hopefully you remember this is when two organisms are in close contact and close interaction for extended periods of time. So when we look at the three types of species interactions that are symbiotic, we have mutualism, where both species are going to benefit. We have species one and species two, they're both equally gaining benefit from it. We have parasitism. In parasitism, the parasite's going to benefit, the host is harmed. And then with commensalism, we have one benefiting and the other one has no harm or benefit whatsoever from it. It's important to note too that mutualism is not cooperative. It's not that they're interacting with one another and talking and coming up with a plan. It's just an interaction that's close that happens to benefit both of them. It's not planned. It's not tried to benefit both of them. It simply benefits both of them by chance. Then when we look at the non-symbiotic, these are going to be where they're not going to be an interaction for extended periods of time. It's going to be a short one and done type of thing. And that's going to be competition and predation. And with predation, if you remember back, we have the predator being benefited, it's gaining its food, and the prey is harmed. It has that negative. Parasitism and predation are the same interaction as far as benefit and harm goes. But if you remember back to when we talked about those, we said the big difference was predators try to kill and eat their host or eat their prey. Parasites want to keep their host alive in any way possible because that's their food source of food. They want to keep it alive because they're gaining nutrition from that host species. And then when we look at competition, again, we have two different types of competition. There's interspecific and intraspecific. Inter is between two different things, two different species, I should say. And then intra is within the same species. So if you're fighting with your family members right now on trying to see who's going to get to play the next game of PlayStation, that would be intraspecific. You guys are the same species, you're part of the same family. If you were fighting with the cat for the last bit of food in your house, then that's interspecific. You're fighting amongst two different species with it. So those are the species interactions we have. And our next unit of topic is going to be our terrestrial biomes. And when we look at our terrestrial biomes, there's going to be land-based biomes. There's going to be biotic and abiotic factors that determine what lives in those areas. And the biotic factors are the living factors, abiotic are the non-living. So the abiotic would be things like temperature, precipitation, sunlight amount, all those different things. Biotic factors would be, how many nutrients are being put in by animals defecating and things like that. And if you remember back when we talk about biomes, we always try to link them to temperature and precipitation. If you guys remember those climatograms that we did earlier in the year, we had our bar graphs for the precipitation, and then we had the line graph superimposed on that. And if we looked at that, we could then figure out, we could figure out what type of biome it was based on what temperature and what precipitation we had. And when we look at the types of biomes, we have taiga, temperate rainforest. You guys can read all these. I don't have to read them through. But the basic thing that you should remember, if it's a variety of forest, it's going to have high precipitation. If it's a grassland, it's going to have moderate precipitation. And we'll do moderate to low because some of the grasslands don't have a whole lot of precipitation, like the shrublands here. Those are getting into lower precipitation amounts. And then if it's a desert, it's little to no. You don't want to look at it from a temperature standpoint. Don't just say all forests are warm, because when you're getting into the taiga, you're getting in the temperatures that might be 20 below zero during the wintertime. They get super, super cold. When we're looking at deserts, not all the deserts are hot. Mongolia is a desert, but Mongolia gets very, very cold. When we look at Antarctica, Antarctica is technically a desert. There's very little precipitation that falls, and it's super, super cold. So don't think about all deserts being like the Sahara. They're not going to be these super hot deserts that we see with it. Now, in addition to that, a couple little tricky things with these. The tropical rainforest rather. Remember that those have very low nutrient levels in the soil. So very low nutrient soil. And if you remember back, it's because that constant rainfall, it's really hot and humid, so things decompose very quickly. Since there's nearly daily rainfall, all of those nutrients that normally would break down and seep into the soil just get washed off. When we look at these other ones, the temperate grasslands and the savanna is going to have seasonal fires. And those seasonal fires are important because that's what's going to release the nutrients into the soil. If you watch the end of the Jungle Book and the fire is happening, that's what we're talking about with these seasonal fires. As it starts to get into the dry season and the grasses start to dry out, now lightning strikes or a piece of glass laying on the ground focuses the sunlight and starts up one of those fires. Since these are very, very windy biomes, the savanna and the grassland, those fires get pushed and fueled with unlimited amounts of oxygen. So they burn and they burn off the grasses. The trick to those fires is they burn off the grasses on the surface, releasing the nutrients into the soil. But the root systems below are still intact. So as those root systems are intact, as soon as that fire's gone, now the grasses have a lot of nutrients available to them and the grasses just regrow. So it's only a short-term problem for them. And I think that's pretty much covers the important stuff to know with the biomes. When we talk about aquatic biomes, again, you guys can read through the different types of biomes. When we look at these, it's important to note that it's going to vary based on salinity and nutrient levels. Coffee all over myself. That's wonderful. When we look at the salinity, streams and rivers and ponds and lakes, these are going to be our two freshwater biomes. And it's important that you guys remember, freshwater does not mean drinkable water. Freshwater simply means that it doesn't have salt present in it. If it's drinkable water, it's potable. And if it's freshwater, that just means no salt. This can still be contaminated and polluted, so you don't want to say drinkable and freshwater as synonyms. When we look at these ones down here, now these are our marine biomes or saltwater biomes. And as far as nutrient levels go, we're always going to have differing nutrient levels, but our main ones that have the highest nutrient levels are going to be our swamps and marshes. And those swamps and marshes have the highest nutrient levels because, again, there's lots of decomposition happening there. As the plant life falls into the water, it starts to break down and decompose. When we look at the next, it's going to be the estuaries. And if you remember with the estuaries, it's where we have a river meeting an ocean. So we have the river systems flowing into the ocean. It's getting nutrient input from the river. It's also getting nutrient input from the ocean wave action, bringing those in. So that estuary would be, this area in here, and it's extremely, extremely nutrient rich. As far as the highest biodiversity, we're looking at the coral reefs for the highest biodiversity. Most overall biomass is going to be the open ocean. And again, that's because of how vastly huge the open ocean is. So again, when you're looking for the most nutrients, swamps, marshes, and estuaries, when you're looking for the most biodiversity, it's going to be the coral reefs. And when you're looking for the most productivity overall, it's the open ocean. Sorry, not used to talking this much. All right, now when we're talking about our distribution of life, it's going to be based on rather, these different characteristics. And every organism is going to have that optimal range of tolerance. Remember, we're trying to stick into this range right here, that optimal range, because this is going to be where they survive, grow, and reproduce. When you're on either side of that optimal range, that's whenever the reproduction stops. So if we want to have a growing population where they're surviving and growing, but also going to be producing offspring so the population as a whole grows, we want to stay in that optimal range. That's where everything's in perfect balance and everything's happy. So when we look at that, we have salinity, which is the salt concentration. We have depth of water, which is going to determine a bunch of different things. It's going to help to determine temperature, how far down you go. It's going to help to determine dissolved oxygen, sunlight penetration, nutrient availability, a lot of stuff. So the depth is going to be an important part. We also have turbidity, which is the cloudiness of the water. And again, the cloudiness is determined by how much suspended material is in there, whether it's soil or whether it's dead organic material, algae floating around, it doesn't matter. The cloudiness of the water is going to be determined is what we call the turbidity. That's going to determine how much sunlight can penetrate down, which then in turn determines how much photosynthesis is happening. So cloudiness is going to be a very important thing as well. Nutrient availability and temperature, self-explaining right there. Oops. Go to the back function. Oh no, went to the wrong way. Sorry, guys. I'd like to say that I'm an expert at this stuff, but I suck at it. I'm becoming more and more aware of that as time goes on here. All right, and our last slide that we're going to cover in this video, and then I'm going to take a little bit of a break and come back to it, are our biogeochemical cycles. This is probably the most important thing for the first unit. That's why I want to make sure that I'm covering them more in depth in this review. So the first thing I want you guys to remember is the acronym SCHNOPS. It's going to be carbon cycle, hydrologic cycle, nitrogen cycle, oxygen, phosphorus, sulfur. We don't talk too much about the sulfur cycle or the oxygen cycle in here. We'll touch briefly on them, but we tend to focus on the other four. These are the biogeochemical cycles, meaning life, earth, chemical cycles. This is what provides us our nutrients. Earth is a closed system, meaning we don't have new inputs of chemicals coming from outer space. We get meteorites and things like that, but they're relatively small compared to how much we have available already. So the carbon, water, nitrogen, oxygen, phosphorus, sulfur that we have on our planet right now is the stuff we've always had. So since Earth is a closed system, we have to be able to, I don't know why that just went big. Since Earth is a closed system, we have to be able to recycle those nutrients. And they're going to recycle each other through those biogeochemical cycles. And I'll come back on here in the second video talking about each one in a little bit more specifics. So what I would like you guys to do and leave right now with is, again, the AP exam is going to be 2 questions. It's going to be a 25-minute question and a 15-minute question. The 25-minute question is going to be designing an experiment. So try to walk through this unit in your head as you're reviewing, thinking about what type of experiment they could ask me about. Can I explain it? Can I develop my own experiment? That's what you guys need to keep in the back of your head at all times with this review. That design and experiment question, again, 60% of your grade, you have 25 minutes to do it. That's a lot of stress to put on it. The more we practice it, the less stressful it's going to be.